Starting from the top here, a rational expression is an algebraic fraction where both the numerator and denominator are polynomials. In any rational expression, the denominator cannot be zero. So I've given you three examples of rational expressions here. 3 over x is a rational expression. The top doesn't contain x, but the bottom does. And what I will tell you is that's the real definition of a rational expression. You need a variable in the denominator. You don't necessarily need a variable in the numerator, but you need a variable in the denominator. Since rational expressions are fractions, and this is what we're going to focus most of our efforts on in this unit, looking at the top of the screen here, since rational expressions are fractions, whatever you do to work with fractions, you do to work with rational expressions. So if we're going to be multiplying two rational expressions, we're going to be using the same rules that we would use when you multiply two fractions. If you're going to be adding rational expressions, you have to add them in the same way you would add fractions, because rational expressions are fractions. Okay? If you're going to be simplifying a fraction, you have a certain set of rules that you follow. You're going to follow that same set of rules for simplifying a rational expression. Now, non-permissible values. The value of a variable that makes the denominator 0 is not allowed. Okay? We call that a non-permissible value. And I think I can get back to this program now. We're not allowed to divide by 0. So let's take a look at example 1. Hopefully this will run smoothly now from this page forward. For each of the following, determine the non-permissible values for the rational expression. Well, we're dividing by 5p cubed q. And what that means, everybody, is that p is not allowed to be 0. Because, and this is just by inspection, if you were to put p equals 0 in there, I hope that you're going to see the denominator will be 0. Because you're going to have 5 times 0 cubed times 0, which will give you 0, and you're not allowed to divide by 0. Additionally, I hope everybody sees that q is not allowed to be 0. Because if q is 0, the denominator is 0. I want to point something out to you, and I'm going to be fixating most of the time in this unit on factors. You certainly don't need to write this expression this way, but I'm going to write it this way because I want to highlight to you this idea that everything that's in brackets there is a factor. The 6 is a factor of the top, the p is a factor of the top, the 5 is a factor of the bottom, the p is a factor of the bottom 3 times, and there is a q as a factor on the bottom. And we've talked about this before, but in this unit it becomes excruciatingly important. What makes these factors is that each of them can be written in brackets multiplied by everything else. That's what makes something a factor. So if I said to you that we have this expression, r plus 6 over 6r, and I said, is 6 a factor of the bottom? The answer is yes. Is r a factor of the bottom? The answer is yes. Is 6 a factor of the top? No, because we cannot write the top as 6 in brackets times something. So that's our answer. This is our answer to A. And again, we're just looking at it by inspection. Take a look at B. What are the values of x that are not allowed? Can somebody explain to me why negative 2 is not permissible for x, not allowable for x? Yeah?
Negative 2 plus 2 is just 0.
Right. When I load negative 2 into here, if I were to do that, then I would get negative 2 plus 2 on the bottom of this expression. And quite frankly, I don't care what the top is. If that negative 2 plus 2, which is a factor of the bottom, is 0, since that factor is being multiplied by everything on the bottom will be 0. So it results in division by 0. Gustav, are you able to look at that other factor on the bottom and tell me what x is not allowed to be? Do you want to give it a shot? No? Does anybody want to give it a shot? What's the other non-permissible value? That is to say, what is the other value of x that would make the bottom 0 as well? Yep. 5 over 2, good. And what you can do, and I think we need to talk about this right now, is I think most people, I mean, just look at that expression, they go -2. Definitely, right? But what you can do if you're not sure is the denominator factor of x plus 2 is not allowed to be 0, right? That's a restriction. If I solve that for x, it involves subtracting 2 from both sides. That's where that x is not equal to -2 comes from. If I were to do the same thing here with the 2x minus 5, I would have 2x minus 5 is not allowed to be 0. So I can add 5 to both sides and get 2x is not allowed to be 5, which means x is not allowed to be 5 over 2 when we divide both sides by 2. Are you with me on that? I think sooner or later everybody has to graduate to the point where you would show this work on the left on an exam, on a written response, but everybody has to graduate to the point where you look at 2x minus 5 and you say, oh, it's 5 over 2 that's not allowed. And I don't know. I think when I look at it subconsciously, I actually do what I've got written down here. I do it in my head. I move that 5 over and I divide by 2. Let's try another one. 6y over 2y squared minus 18. So I'm going to tell you right now that there are non-permissible values here. Y is not allowed to be equal to something. What? Or how can I figure out what it's not allowed to be?
Is the non-permissible value 3?
Pardon me?
Is it 3?
It is 3. That's one of them. But how can we find that? Because I know looking around the room, not everybody sees where you're getting 3 from. You solved it as a puzzle, kind of. Like you're thinking, if I put 3 in, I'll get 2 times 9, which is 18. Okay, but what should we always do first? Factor. You cannot do anything until things are factored. If you were to look back at B, B was already factored. If you were to look back at A was already factored, right? It's all multiplied together. When we take a look at C, I can factor a common factor of 2 out of the denominator, and a 2 out of the denominator leaves me with y squared minus 9. Oh, y squared minus 9 is a difference of squares. It factors into y plus 3. Y minus 3. And now we simply inspect, this is your eyeball, we simply inspect the denominator and say, are there values for the variable that will make any of the factors 0? Because if any of the factors are 0, the whole thing is 0 on the bottom. And the value of y that would make this blue factor 0 and the value of y that will make this yellow factor 0 are -3 and +3. So in fact, you had one of them, but there's another one. Plus or minus 3 are the non-permissible values. You have to have things in factored form before you can draw any conclusion about anything or before you can do anything in this unit. D. You know, if by the end of this unit, heck, if by the end of today any of you do this, I think I might have an aneurysm. Like that vein in my forehead is going to start throbbing and I'm going to get all red in the face because then I will have taught you nothing. You cannot do anything until you factor first. And I know that we are not talking here about canceling stuff, but it doesn't matter. You have to factor everything first. So can we factor the denominator? Absolutely. We can factor it This is why we learned about factoring in quadratics before this unit. This is 2x and this is x. It's got to be 5 and 2. I think if we put a 2 here and a 5 here and make the 5 positive and the 2 negative, I think that does the trick. But and don't just blindly write it down. I'm saying you should know how to factor that. If I FOIL that out, I do in fact get 2x squared. I'll get plus 5x and minus 4x, which will give me plus x, and I get minus 10. So now we're able to look at that and say x is not equal to 2. Because if it's 2, then x minus 2 is 0. And Gustav, what do you think x is not equal to here?
I'm gonna say 5 halves.
Negative 5 halves. Do you see why?
Yes.
Okay, so negative 5 halves. And the non-permissible value in most of these will always have the opposite sign of what's there. If you're not sure where we are getting the negative 5 halves from, you're saying to yourself that 2x plus 5 is not allowed to be 0. So that means 2x is not allowed to be negative 5, and that leads you to this statement. So those are the non-permissible values for D. I'm going to cross my fingers and hope that my next pages on this document are okay. We're going to talk now about equivalent rational expressions. Whenever you multiply a fraction by 1, whenever you multiply anything by 1, you don't change the value. If I take 11 times 1, I get 11. 72 times 1 is 72. But when you're dealing with a fraction, you may multiply by 1 in such a way that you get something that looks different, but since you've multiplied by 1, it isn't different. As an illustration, I've got in the center of the screen here 3/4 as a fraction. So this fraction that I'm talking about, you can think of this fraction as my original fraction. This is where we're starting. If I multiply 3/4, which by the way is 0.75, if I multiply 0.75 by 5 over 5, the rules for multiplication of fractions say that you multiply across the top and you multiply across the bottom, and I get 15 over 20. Correct? Is 15 over 20 the same as 3/4? Well, it doesn't look the same, but it is the same, isn't it? 15 divided by 20 is 0.75. We've multiplied by 1, but we've got two different fractions, and we call those fractions equivalent fractions. If we extend this idea to rational expressions, we can do example 2. I have a rational expression of 5g over g minus 3. And it tells you that g is not allowed to be 3 because that's a non-permissible value. Quite frankly, everybody, if you look up here, I shouldn't have to tell you g is not allowed to be 3. It's staring you right in the face in the denominator, isn't it? But very often on exams and in typed work, we will have it written. So what are some different equivalent rational expressions? Well, I could take 5g over g minus 3, and I can multiply the top by 2 and the bottom by 2 and get 10g over 2 times g minus 3. I have a question for you. Why do you think I didn't multiply that 2 through on the bottom? Josh?
Actually, I don't know. I was going to say, so you can make it 5g over, or, yeah, 5g over g minus 3.
Yeah, well, and it's kind of right. And then you paused and you went, well, wait a minute, then we're going back to the original question, right? But that's not what's important. What's important is everything always wants to be in factored form. We want things to be in factored form in case we can do some good stuff with them. And you're right. We could now see that you could cancel a 2 with the 2, which is kind of where we're going today in this unit and in this lesson. So I would just leave it in. If you want to write 2g minus 6, you certainly can. You don't have to leave it that way. Can I do something like this? Can I take 5g over g minus 3 and multiply top and bottom by g. Why not? G over g is still allowed. It's 1. So I get 5g squared over g times g minus 3. You're still with me here? The weird thing is, by multiplying the top and the bottom by g, we've introduced another g, haven't we, in the denominator. We've got a non-permissible value of 0 now for that g. But I wouldn't get hung up on that. That's not important. All right, take a look at example 3. What is happening to the first rational expression to turn it into the second rational expression? Who can tell me? Paige.
It's being multiplied by x. Like an x is being multiplied.
Right, on the top and the bottom. So we're multiplying the top by x and the bottom by x. And by the way, if that's not clear, rather than me writing x squared plus 5x, if you take a look at this, I can factor an x out of that and have x plus 5. And you can see that in the original expression, there was an x plus 5. There was an x plus 5, and there was a 7. And there's a 7 here, and an x plus 5. There's your x over x that we've multiplied by. So the answer to the question is we've multiplied top and bottom by x. What's going on here? This is a little trickier. This is. It may be obvious to you, but be careful on what you conclude. We're going from negative 4 times p minus 3 over p squared minus 9. We're going to negative 4 over p plus 3. What's happening to the top and the bottom? Well, before I take an answer, do you agree that this is harder on the brain than what we just did? So what should you do first to make your life easier? Factor. Seeing factors allows you to see things you wouldn't normally see. This is negative 4 times p minus 3 over a difference of squares is p plus 3, p minus 3. So now, what have we done? Paige.
The p minus 3 was factored out of the top and, or like taken out of the top and bottom. I don't know the word.
There's a word we can use here. Well, we factored it, and now what? Now this, and I think this is important to slow down and talk about. This is a factor of the top. This is a factor of the bottom. Where did they go? Poof. Where did they go? What mathematical operation happened here? They canceled. And that's what you're used to saying. The actual operation when you cancel is we divided the top and the bottom by the x minus 3. And I'm using this as part of an example in the early part of this lesson to highlight to you what are you allowed to cancel factors. Okay, you can only cancel things that are factors. And finally, this one, well, how are we going to figure out what we multiply the top and the bottom by? The answer is you have to factor the expression that we get. Let's see, I can factor a 9 out of the top and be left with r squared minus, well, I can factor a 9r out, actually. And be left with r minus 1. I can factor out of the bottom an r and be left with r squared minus 1. Are you guys still with me here? That r squared minus 1 factors as a difference of squares. if we look at what we had to begin with, what we had to begin with was a 9 on the top and an r plus 1 on the bottom. There's our 9 on the top. There's our 9 on the top. There's our r plus 1 on the bottom. What additional stuff has been sprinkled on the top and the bottom? There's an extra r as a factor. There's an extra r minus 1. So we've multiplied the top and the bottom. We've multiplied the top and the bottom by r and r minus 1. I want to just pause and let you know here, the questions we're working on so far are not exam questions. They're just warming you up to the idea of what we're going to talk about now, which is the most important aspect. Okay? Any questions with that example, though? All right. I want us to simplify 1500 over 270 without using a calculator. We might have to rely on a calculator to find factors of those things, but I would prefer not. What I want us to do is to write 1500 in factored form, and we do not have to do this in one shot. Can I cancel? Well, we won't cancel anything yet. Okay. Can I factor things further? Can I write 15 as a product of things? 3 and 5. What about 100? Can I write 100 in factored form? Well, that's 10 times 10. I hope nobody is overly confused by me saying 2 times 5 times 2 times 5. Because 2 times 5 is 10, 10 times 10 is 100. Still with me? On the bottom, 27. This is actually from the previous unit. We did a lot of this. 3 times 3 times 3 is 27. And 2 times 5 is 10. And I don't think we really needed a calculator to get that far. So my question to you now is, can I cancel this 5 and this 5? Sure. Why? They're factors of the top and the bottom. So it isn't that they're right beside each other. I mean, I could have said, can I cancel these two 5s? It doesn't matter, because factors are things that are just being multiplied. Can I cancel a 3 with a 3? Can I cancel a 2 with a 2? Absolutely. So that's where the concept of canceling comes from. And I want to get rid of these highlights because they're just going to get in the way of this next bit of business. That's where the idea of canceling comes from, where you say, well, I have a 3 and a 3, I have a 5 and a 5, I have a 2 and a 2, and that's it. I'm done. The only thing I have left on the top is 5 times 2 times 5, which you should be able to figure out is 50. And the only thing I have left on the bottom is 6. Oh, no, is 9 rather. So I get 50 over 9. Capiche? Just take your calculator, take 1500 divided by 270, and see if you get 50 over 9. Which I want to say is 5.5 repeating. And you do. Listen, we're not going to be canceling numbers that way, but we have to learn that when you simplify a fraction, you're canceling factors that are common to the numerator and denominator. And now this is the main thrust of this lesson. If I said to you, simplify this rational expression, can somebody explain why I am not allowed to do that? Yeah. Right. The x isn't being multiplied on the bottom by the whatever else is there. It's x minus 3. In other words, the x that I've canceled on the top and the bottom is not a factor, and I'm not allowed to do that. So I can't cancel anything right now unless I were to factor things first. So if you wanted to simplify that expression, you would need to factor it. So let's take a look at what would happen. There's the expression. If you factor the numerator, you want to just double check that, make sure that's factored correctly. Now I can see that there's an x minus 3 on the top and the bottom. See how I put it in brackets? You don't need to do that. Now I can cancel the factors, so it turns out it's equal to x minus 2. A point I want to make, though, right now, before we finish off this lesson with the last set of examples, is this. This non-permissible value survives the onslaught of canceling. It doesn't matter that that x minus 3 canceled. X is still not allowed to be 3 in that expression. I know you might look at that and go, well, I can put 3 in there. 3 minus 2 is 1. I'm telling you, you're not allowed to, because you weren't allowed to in the original expression. All right, final example. This is the most important part. Simplify the following and state the non-permissible values. Let's do the NPVs first. P is not allowed to be 3 and negative 3. Is everybody okay with that? Okay. Can we simplify this at all right now? What do you think, Nate?
Yes.
What can we do?
You can cancel the P minus 3s.
Excellent. I can cancel the P minus 3s. So my final answer is negative 4 over P plus 3. I just want to check to see if I have to change your note package. Are you missing a bracket in your note package? You are, eh? Okay. We still have to write the non-permissible values. I'm going to put plus or minus 3. You don't always have to, but I'm going to get in the habit of doing it. Nate, you said we can cancel the P minus 3s. Why?
Because they're both factors.
Because they're both factors. Excellent. There's a P minus 3 of the factor as a factor on the top and on the bottom. Can you tell me, Nate, why you know P minus 3 is a factor of the top and the bottom? Right. They're both multiplied by their surroundings. It's not P minus 3 and then plus something. Let's try another one. Can we, well, let's do the non-permissible values. P is not equal to 0. Q is not equal to 0. Because if P was 0, the bottom would be 0. If Q was 0, the bottom would be 0. Can we cancel anything here? See, you actually learn how to simplify this in grade 9 and 10, but you don't talk about factors then. What can we do here, Christy?
The P's and Q's.
Right, there's a whole bunch of P's and Q's. And I'm going to actually write this out as 2 times 3 times P times P times Q times Q times Q. Because after all, Mr. Way said factor everything first. You don't need to write it that way, but this is factored. On the bottom, we have 3 times 5, and then we have P times P times P times Q. So what can we cancel? Well, there's a 3 and a 3, a P and a P, another pair of P's, there's a Q and a Q.
Mr. McBride, please contact room 160. Mr. McBride, please contact room 160.
And I think that's it. I get 2Q squared on the top over 5P. Now, could we have gone in this particular question to this answer without that mess in the middle? Because quite frankly, visually, I find that confusing to look at. I do anyway. I had to look twice to make sure I didn't miss anything. The answer is yes. Because this is a monomial over a monomial, feel free to just divide. Got an extra set of brackets there, but it doesn't matter. 6 over 15 is 2 over 5. P squared over P cubed is P on the bottom because 2 of the P's cancel. Any questions with that one? Okay, pretty straightforward still. All right, so now, is there anything we can cancel? It's factored already. Are there any factors that are identical on the top and the bottom? No, there aren't. Can we arrange it so we have some factors that are common to the top and the bottom? I'll tell you, it can be arranged so we get an identical factor on the top and the bottom. And your job right now is to see if you can figure out how. No, eh? Do you notice that that 5 minus k seems backwards to you? We don't often see factors like that. We usually see k minus 5. Well, if I take 5 minus k and I factor negative 1 out of the 5 minus k, the negative 1 taken out of positive 5 gives me negative 5. And the negative 1 taken out of negative k gives me positive k. Just take a breath here. Multiply this out. Can you confirm that you'll get 5 minus k? Okay. And then k plus 3. And this is over 3 times k minus 5 times k plus 6. I am going to rewrite it. I think most of you see what's going to happen here, but I have 2 times negative 1. Might as well just marry those together and say negative 2. Negative 5 plus k is k minus 5. Then we have the k plus 3. Now can we cancel something? Well, yeah, the k minus 5s. And I guess what I'm getting at is when you have anything that looks like this, that will be equal to negative 1. Because if I factor a negative 1 out of one of them, whatever I have left cancels. These are not conjugates. Don't confuse these with conjugates of a plus b, a minus b. That's different. So this is always going to be equal to negative 1. Our final answer is negative 2 times k plus 3 over 3 times k plus 6. K is not equal to negative 6. Are we in agreement with what I've written there as the final answer? Really? Aren't I missing something? K is not equal to 5 as well. It doesn't matter that it went away. You still have to keep that non-permissible value. All right? Take a minute and look at this one, D, and ask yourself, what do we have to do here that we didn't have to do in A, B, or C? Factor. That's right. I like that you did this. Factor. You have to break it apart into pieces so you can see the pieces that cancel. Common factor in the numerator of 4. Denominator common factor of 3, which reveals in the denominator a difference of squares, which is factoring now into x plus 3, x minus 3 in the denominator. We also have this factor of 3. Cancel, cancel. Whatever you have not canceled is what's left. 4 over 3 times x plus 3. X is not equal to plus or minus 3 because of these two non-permissible value factors. I would put it to you another way about this whole multiplying through. Why multiply this through? Well, that's maybe the answer to the question. Why would you? What good does it do to multiply that through? It doesn't change anything. Leave it in factored form. Any questions with D? E? Okay, well, we have to factor. Geez, I've seen some crazy things, and I know sometimes you get tired. I get tired too, but you can't start doing stuff like this. I've seen a student do something like this. That's negative 7 over 23. Fractions don't work that way. You cancel things because you're multiplying on the top and the bottom by the same thing. So don't go crazy. We need to factor this. Well, this is good practice for factoring. These are both quadratic trinomials. Early on, when we reviewed factoring back in Unit 2 or 3, I used this unit as an illustration for something that if it's going to take you 5 minutes to factor one of these things, then you're going to spend 10 minutes on this question before you've even gotten to the rest of the question. What two numbers multiply to give negative 10 and add to give 3? 5 and negative 2. What two numbers multiply to give 15 and add to give 8? 3 and 5. So the x plus 5's cancel. You're left with x minus 2 over x plus 3. Non-permissible values, if you need them, would be x is not equal to negative 5 or negative 3. Any questions with that one? Would it have mattered if we had written this? Would I still be able to cancel the x plus 5's? Definitely. The order in which you multiply doesn't matter, so the order of where they appear shouldn't matter. You can still cancel because they are still factors. Final question. Well, we have to factor. Ultimately, most of this unit is a test of your ability to factor. And, you know, today is just simplifying rational expressions. Tomorrow we will multiply. The next day we will look at dividing. Then we'll look at adding and subtracting. And every time we go to a new lesson, the level of work that's required to get an answer is bigger. So you have to be able to factor as a first step. And you have to be able to do it reasonably quickly. 2x and x. I would guess this is 2x and 2x. It may not be. It may be 4x and x. And looking at it, I believe it is 4x and x. I think if you put a 1 here and a 3 here, you will not be able to squeeze negative 13x out of that. The only way you can do that is if one of these two x's is a 4x and the other one is a 1x. I think if we put 4x here and 1x there, we can get negative 13x out of that. Let me demonstrate to you just a little tip. It may not be that big of a deal, but as the number of things that you have to factor grows, it might be helpful. Do you think I would ask you to simplify this if it didn't simplify? Probably not. Which tells me that I'm guessing this is going to be a 3. Because I got an x minus 3 on the bottom. Why would I ask you to simplify it if we couldn't get a factor on the top and the bottom that are the same? That would make this a 5 because we need 15, and it would make it a positive 5 because we need negative 15. You can just confirm that you'll get negative x out of that. And the x minus 3's cancel. And you're left with 2x plus 5 over 4x minus 1. And x is not equal to 3 or 1/4. And I'll give you a minute here to roll around where I'm getting x is not equal to 1/4 from. So any questions with that final example? All right. Listen, simplifying a single rational expression means factoring everything and then canceling. Non-permissible values are values of x that make any of the factors in the denominator 0 before they're canceled. And an equivalent rational expression is found by just multiplying top and bottom of a fraction by something. Do you have 15, 17, 19, and 22 in your handout?
Yeah.
You do? Just curious what they are. I think I've said don't do them because I think there's more than enough to practice here. So I think if you got practice with those, that would be fine. Yeah, get to work. Just let you know, I have to be away tomorrow, so Mrs. Lindahl will be in, and I will stay after school today and make a video of tomorrow's lesson. But what that means is you will not have a chance to ask questions about this stuff tomorrow. So for Monday, we'll go over today's stuff and tomorrow's stuff. No worries, okay? And the stuff you're doing tomorrow is pretty much almost the same as this. Yeah. So you got about 20 minutes, lots of time here for practice today.
Where's Jay?
And then tomorrow,